Here you can see the cassette being placed on the RM3 machine. After checking for defects in the cassette, the perfusionist will use thumb screws to hold the cassette in place on the RM3. Here we're pointing out various parts of the cassette, which include the bubble trap, the manometer line, the arterial ports. Of course, this is where we're going to measure the pressure. Bubble trap that I pointed out before, the arterial ports leading to the kidneys, and the membrane oxygenator. This is the reservoir for the perfusate, which leads into the ventricle. And of course, this is where the solution is pumped, which will eventually go through the heat exchanger and then into the kidney. The flow probes will be placed later. Once the cassette is snug, the ventricle is placed in the pump head. The stroke volume knob can be opened to decrease the pressure at the pump head. Next, the circulation pump is connected to the heat exchanger. This can be done simply by placing the clamps in place on the heat exchanger. Then the flow manometers can be placed on the arterial ports. Of course, here we will measure flow directly to the kidney. It is important to recognize that both right and left manometer probes must be placed appropriately. Now you're seeing the technician place the temperature probe into the cassette. It is important to note that you place the temp probe into the cassette only hand tight prior to placing the probe into the machine. This prevents the technician from damaging the temp probe. After the temp probe is placed, then the air line can be connected. This will provide room air across the membrane oxygenator. And then finally, we will connect the pressure line to the machine. But we won't do that until the perfusate is added to the machine and the pressure is brought to room atmosphere. Initially, we will raise the ventricle from the pump head and debubble the line. You can see this is done by allowing the bubbles to run through the line and then are of course caught in the bubble trap. It is important to recognize that you don't want to allow the level of the solution to go high into the bubble trap. We will initially turn on the circulation pump, which begins the process of decreasing the temperature of the perfusate. Next, we will zero the pressure to the atmosphere in the room, and then we can connect the pressure line and open the clamp and begin to monitor the pressure. You can see we have zeroed the pressure here at this point. You can read the temperature as well as pulse per minute rate and pressure. Now that the RM3 is ready to accept the kidney, we will place the left kidney in the cassette and begin perfusion. Please note that the left kidney is placed on the left side of the cassette as the perfusionist views the machine. Initially, we place the kidney in anatomical position with the left vein on top. It is important to note the various structures, including the ureter. There's a slight modification that's made to the cassette in that we reduce the length of the arterial line, which provides a better approach as we place the pilling clamp into the cassette. The perfusionist could provide a small amount of pressure to the arterial port, as you see here done with this clamp. And then the person responsible for placing the kidney on the pump can debubble the line. Of course, both the renal artery and the clamp should be completely filled with perfusion solution. Then the perfusionist is notified that the kidney will be placed on the pump and the clamp is placed into the arterial line. After the kidney is placed into the machine, then the perfusionist can increase the stroke volume, which increases the pressure to somewhere between 40 and 60 millimeters mercury. Next, the person who placed the kidney on the machine should check for leaks around the clamp and from any accessory vessels. It's also important to note that there are no kinks and that the arterial line is not kinked, or that the artery is not kinked in any way. It's also important to note that there is effluent from the renal vein. Finally, the ureter should be placed under the renal vein, and the effluent from the renal vein will keep the ureter moist. It's also important to note that the kidney should not be against the sides of the cassette, as this would decrease the amount of perfusion to the kidney. It's also important to note that the kidney should be completely placed on the left side of the cassette, as we want to measure the effluent flow from this kidney. Now we will show the placement of the right kidney on the perfusion machine using the direct cannulation method that we talked about earlier. As you can see, the Teflon cannula is placed into the renal artery using the snare that we've developed in our lab. We utilize a vessel loop and a piece of IV tubing, which works very well to hold the cannula in place. Once the Teflon cannula and the renal artery have been debubbled, then the same technique is used to place the cannula into the arterial port. The perfusionist is asked to decrease the pressure, and then the cannula is placed into the arterial port. The same techniques to check for leaks and also to check for effluent from the renal vein. After the ureter is placed and both kidneys are determined to be in the appropriate position, then the lid of the cassette can be closed. We hope that you found this video enjoyable and that it will be helpful in your practice of organ preservation. The concept of organ preservation arrived at Waters in the late 1960s, as researchers in the company were developing a permeable membrane oxygenator for cardiopulmonary bypass systems. Waters delivered the first commercially available pulsatile perfusion machine in 1972, and then followed that with the first disposable cassette, which was introduced in 1975. Waters Medical Systems continues to lead the field of organ preservation with innovative yet reliable pulsatile organ preservation technologies. If your center has questions about perfusion or desires to initiate pulsatile perfusion, Waters can provide you with a starter's kit which includes everything you need to begin perfusion. You can contact Waters at 1-800-426-9877, and I am available to help your teams should you need on-site assistance or continuing training. Thank you so much.